Yo, what's going on? So the last video, I came out with more questions than I went into the video with. They said something about like TIG and like Flux stuff and some other stuff. So I went to the next video. We'll see what these guys had to say. If I can kind of dial it in a little bit, figure out what's going on here. Um, welcome.
Hey, welcome to the shop.
Hold on, I didn't pay attention. So we've got, what is this guy? This is the first one. That's just like a clamp. What that is? I don't know what that is. That looks like a really scuffed thing for pumping gas. And that looks like how you check like maybe a bike tire pressure. So it's like fine tuning, like I don't know, some sort of like, oh, it shows it right there. Okay, so like we got like fine tuning right here. You got like whatever this guy is, he does like broad welds that are kind of like general, because you don't see a whole lot of these rivets in there. And then you got this guy, you got a fuckload of rivets. So maybe this is like for really strong welding, and this is for like kind of like cheap flimsy welding, and this is like detailed shit. And then I don't know about this one. I don't really have a good like view of that.
Hey, welcome to the shop.
Thanks.
So there are a lot of different kinds of welding out there. I'm going to break down the four most common types from a high level, so you'll know what you might want to learn or you might want to learn next. Now, if you actually want to learn how to do one of these, I've put videos that I made down in the description below, so you can link to those.
Brother, I will burn my face off. That's why I'm watching a YouTube video.
And see step by step how to learn them. But today we'll just talk about what they're good for and how they kind of work. Now let's start off with stick welding. It's also called shielded metal arc welding or manual metal arc welding or rod welding, a bunch of different names, but all called stick welding. It uses these electrodes that look like a stick. Now this is actually an ingenious invention because it solves multiple problems.
This is the lightning weld from the last video.
All in one simple package. So the first thing that you have in the center is you have a rod of metal that's similar to the metal that you're welding. In this case, it's steel. And I'll connect it to an electrode holder like this, which is an electrical...
So hold up. So he used the same word, similar. No, he used a different word. Last one was like different or indifferent, right? This one he said similar. So you have to have different sticks with different metals, because the different base metals only react to certain binders, right? So there's like a bunch of like I don't know, like 8 different variations of sticks, right?
Clamp that has a handle on it, and that allows electricity to flow from my welder up through the rod.
That's a fucking hairdryer, bro.
Put this other clamp on my welding table, or you can put it on the part you're working on to complete a circuit. And so you just touch the end of that rod there, and that makes a short circuit and will create a spark that starts an arc. And the arc is where electricity jumps over a gap and creates a tremendous amount of heat. Now when that happens, it melts your base metal.
Wait, what? He didn't plug it in?
And that allows electricity to flow from my welder up through the rod. And then I'll put this other clamp on my welding table.
Oh, he did plug. Okay, so there's 2 clamps and then a hair curler.
Where you can put it on the part you're working on to complete a circuit. And so you just touch the end of that rod there, and that makes a short circuit and will create a spark that starts an arc. And the arc is where electricity jumps over a gap and creates a tremendous amount of heat.
That's what happens, melts it.
It melts your base metal.
Yep.
And it also melts off the center of this rod and adds it to it. That's why you get that crowned up shape on your weld. The other thing that happens is this outside coating that's called flux burns off, and it protects that molten metal from the air so that it doesn't get contaminated by oxygen and other things in the air.
Okay.
So it's really genius how that works. Now,
so does the flux go into the weld? Like, does it sit on top of it, or is it inside of it, or does it just like not go in it at all?
As you move along, your rod will burn down from long to short, and let's go ahead and do a little demo. So you can see as I'm welding here, the electrode is just maintaining that nice short arc, and that's because I'm moving my hand in closer to the metal as I move.
So it doesn't look like he's stopping, but yet every time I see a weld, I see those little semicircle grooves. Like, what makes the grooves? Is that like the frequency of the short that's going through the metal? That's like every time that the short happens and it melts the metal, that's a new little ring? Or is that like a part of his hand not being super stiff? Like, what decides that? Because it's different for every tool.
Along, and it's just, you've got that bright spot where it's really hot, it's depositing that metal in, and it's also burning off that flux and leaving a coating on the top of the weld called slag.
Slag is the leftovers of the flux when it gets left on top. Got it.
Now at the end of the weld here, you can see that slag coating remaining, and I'll go ahead and just remove it with a tool called a chipping hammer. And after I rake that off and clean it up, you can see I have a nice result. So stick welding is...
I mean, honestly, I think the slag looks better. I hate the way welds look. It just does not look good, dude. The other one at least looked like, you know, like normal. It looked like a smooth surface. That's weird, man. And I've talked like welder friends of mine. They're like, "Oh man, these welds, don't they look good?" And I'm like, "No, dude, that looks like shit."
Really good for a few reasons. One, the equipment is inexpensive, so you can have a basic arc welder like this Lincoln.
A poor man's welder.
Or this is another stick welder that I picked up for about $100 on Amazon that works pretty well also. And so it's very portable, very simple. You just need one of these and some rods along with your safety gear, and you're basically in business. You're ready to go. Some of the drawbacks are that slag coating that it leaves. So I wouldn't use it for like auto body sheet metal. That will be more of a challenge than other processes. I also...
If anybody watches this, I don't know if he's gonna watch this shit or not. Some idiot learning about welding. But if somebody knows like this shit, like, is it hard? Like, is it actually hard to start learning to do? Like, I'm sure that like the first 100 times you do it, you screw up immensely. But like, is it hard? Like, is this something you could actually do to like, I don't know, like repair? Fuck, I don't know, things that break. It's not good. Like a coat rack. Like, can I get a metal coat rack and weld something onto it and it work with this shit? Or is it just kind of like a hobby thing?
So typically you won't stick weld anything that's thinner than about 1/16 of an inch or 1.5 millimeters, though you can if you do it right. But
wait, what did he say? I don't know.
I usually try to avoid that because it becomes pretty challenging to avoid burning through. But it's really good for anything that thick or thicker, especially good for structural things like welding up furniture, trailers, if you want to build a smoker, those kind of things.
It's smoker?
Good for all sorts of things like that, just general purpose work and repairs. So really good process. It's used a lot in industry still, especially on the...
What if I got like a sword and I want to like weld another sword onto it?
Pipeline. Next, let's talk about flux core welding, and it's basically...
Or like a fork, and then I want to weld like a spoon onto it and make like a spork like you get at KFC, but we don't get those up here because there's like one KFC that's up here. Well, there's two, but one of them's on the other side of town, and the other one is like they don't have like a great management team. So if you get them when they make the food, it's amazing. But if you don't, then you're running like a 50-50 chance of getting something that's been sitting there for a minute, and then the grease gets there. It's fucking terrible. We don't go to KFC anymore.
The same process as stick welding in that you...
But I would like a spork.
Metal through an arc, and
I'd like to make my own spork. That'd be cool.
But imagine taking the stick welding rod and you turn it inside out. So you take the metal and put it on the outside of the flux, and then you wind that around a roll and you feed it with a motor instead of feeding it manually with your hand.
Well, that's stupid. Why would you ever do that? Why would you put the flux on the inside? Because the flux is what's supposed to keep all the metal from getting fucked up from the air. You put the metal on the outside, then you're just going to have a bunch of weird metal that gets gets messed up, and now you're protecting the thing that's supposed to. You're putting a condom on the inside, man. You don't do that. That's not. Don't do that.
And that's what you have here is this feeding mechanism, and you push it through a tube and out a gun. Now, some of the advantages here are, one, it's easier because you don't have to worry about striking an arc. It kind of happens on its own when you push the button. Also, you just maintain the same distance, and you don't have to stop when your electrode runs out. So it's definitely much easier than stick welding to learn how to do.
Oh.
It can also be done with relatively
inexpensive equipment. That's why.
This is just on a basic flux core welder from Harbor Freight that's less than $200, and there's other similar ones than that.
But why does it have a flux on the inside of the metal? I don't understand that. That doesn't make any sense at all. Unless you're using impure metals? Like that doesn't make any sense, dude.
This one I've had for a little while and use it from time to time, and it's worked well. Or you can use basically any MIG welder. So if you know you're going to want to, learn to MIG weld one day or add the gas cylinder to do that, you can get a MIG welder and set it up for flux core now. And then grow into it. So it's really good for that. It can weld, anything from thinner sheet metal all the way up to this one's rated for 3/16 of an inch. But there are industrial processes that weld extremely thick things using heavier duty equipment with flux core process. So it's good for all of that. You still have that slag to deal with, right? So watch as I weld along here. You can see I'm just maintaining a steady distance with my arc. Between the end of the gun and the workpiece and moving along, and it's depositing metal in just the same. And at the end, after I remove my slag, I got a pretty nice...
I could kind of see this, though. I could kind of see, like if you just needed a little something to do that. Like, I can definitely see that. You drill some holes through it, and you got, like, a little latch or something. Like, I'm in a couple of years going to be buying some property, or I have the property. I'm going to be buying a house, but not on it. So, like, I guess there's, like, some stuff you could use it for.
Result. Now let's move on to MIG welding.
Stick welding definitely looks like more fun, though.
The process I use the most in my shop because it's fast to run, it doesn't leave any slag coating, and the reason for that is it doesn't use a flux. So let's look at the equipment here. You can see that there's this roll of wire, and it looks like copper wire, but
everybody's talking about flux. Flux is how you keep your shit clean. Why would you abandon the flux? Flux seems like such an important part of the process.
It's actually steel wire coated in copper.
Like, you're getting rid of the condom at this point. Like, I get it. I get the thing. Oh, that guy was using the condom completely wrong. But like, why you gotta raw dog it? Like, why would you do that?
Copper to protect it, and that wire.
He just explained why.
Flux. So let's look at the equipment here. You can see that there's this roll of wire, and it looks like copper wire, but it's actually steel wire coated in copper to protect it. And
you didn't get rid of the flux. You just traded it, man. You just got a different brand.
That wire gets fed through and out a gun the same way as with the flux core welding, except this time there's a nozzle around the outside and shielding gas, which comes out of a gas cylinder, and that's either carbon dioxide
shielding
or argon,
gas,
or a mixture of the two most of the time. That gas will
protect the copper that's around the metal you're actually using to weld.
Protect the weld pool instead.
Got it.
That's nice because you don't get the slag. So
all of this to remove your slag, though, that seems like a lot of risk. That seems like a lot more steps than just chipping away some slag. I don't know.
It's really good for anything from thin sheet metal. It's great for auto body work. It's great for all sorts of things. Clear up. My machines will run 3/8 of an inch thick material in a single pass, running on 240 volts.
Maybe it's when you get to the thicker projects. You have all that slag, and it gets in the way of the actual project, so you're able to do bigger and badder shit because you don't have to worry about the excess. That's like a get good scenario. Like, once you're no longer shit, you get to use this.
Volts. So that's with a relatively small machine. So it's good for many things. You can see as I weld along,
like
here,
you're no longer the
just,
water boy of welding
doing a
at that point.
small oscillating motion, and it's filling in that weld, but I don't have that slag on the top. And so after I'm done, it's just really nice and clear and clean. Now, one of the drawbacks to MIG welding is it'll be more expensive than either flux core or stick welding for the equipment, because one, the machines are typically a little...
Well, you need the gas and you need the copper. Yeah, I can see that.
More expensive, and two, you need that gas cylinder to go along with it. So keep that in mind when you're making your decision. But like I mentioned before, you can start out with just the machine and run it on flux core wire, and then get the gas cylinder at some point when you want to. It's also less portable because you need to take that gas cylinder with you. Finally, let's talk about TIG welding, or...
Let's fix the bicycle. All right, it's been flat for 2 years. We got to fix that bike.
Gas tungsten arc welding, it's often called. And imagine the MIG gun that we had before, because it has the gas nozzle that comes around the outside. But instead of wire feeding out through the center, just put an electrode that won't melt. And this is made out of tungsten alloy, and it's similar to,
So tungsten's not iron?
On a light bulb, you'll have a tungsten filament because it can get hot and not melt in an old-fashioned light bulb. And so you can create that arc and concentrate the heat there, and you decouple that from adding metal to it. And so that makes it work really well for precise work where you want to have really fine control. So it's the most well-controlled.
This is how you bedazzle as a welder.
And precise of the processes, though the most challenging to learn. So in order to add that filler metal, you'll just use an additional rod, and you'll feed that right into your weld pool. So watch as I run this here. I'm just creating...
Oh, it's got the gas, and it's just like a super hot pokey thing, and then you put metal next to it, and it melts. That seems like you would fuck it up pretty quick. That seems... This is how welds get messed up, I'm pretty sure. Like this... This seems a little sus.
Creating that weld pool, and as I move along, I'm just adding that filler metal right to the leading edge of the pattern it leaves here on this.
Just don't like that
weld coupon. And you can use TIG welding for aluminum. It's the ideal process for welding aluminum, but you will need to get a machine that'll output alternating current, or AC, as well as DC, and that'll increase the cost of the machine.
AC/DC?
So as far as cost goes, there's a gas cylinder similar to MIG welding, and TIG welding machines are, in a similar price range to MIG welding machines, with the alternating current options being on the higher end of it. So, you're fairly similar there in terms of price for the machines and portability.
Wow, I'm a bigger fan now you're talking about AC/DC. Maybe this is the right way to weld.
One thing to keep in mind is almost all TIG welding machines can be used to stick weld. So I've taken my TIG welder before and just used it for a stick welding job. So that is an option for you.
Okay, so basically the TIG welder is better than the stick welder in every way. It's just way more expensive.
If you get that. Now let's just talk for a second about multi-process machines.
And I guess you could screw it up more. And it would be kind of redundant with the flux. I mean, I don't know.
And those are machines that are available to do more than one thing. Like I said, pretty much any TIG welder will stick weld also. And now there are machines that are MIG, TIG, and stick, and they'll run flux core also. So you can do all of these with one machine.
It's like a Swiss Army knife.
Just one thing to keep in mind is those typically on the TIG function might be a little more limited in the way that the arc starts.
I kind of want to know how much of each one costs. You know what I mean? Like, if you're going to show me like 4 different options and be like, beginner, medium, expert level, badass, I can build a boat with this thing. I want to know material costs. I want to know how much baby's first weld costs, with the stick and the stuff and actual welding thing, all the way up to this bike pump looking motherfucker. How much does that cost, and how much does the raw I guess you know, a raw rod of welding material gonna run you, you know.
They're usually
Well, how do you get that? Like, how do you? I guess you just melt it down, right? You would melt it down, and then you would shave off however thickness of each piece it would be to use it, right? Like that's what you would do, and you would sell them off, and that's what people would use to weld. Maybe, gotta be, or maybe you just put them in like you'd melt it down to like a liquid, and then you would put it into a cast.
a lift arc, and we don't need to get into too much detail on that, but it isn't as good as some of the dedicated TIG machines as far as starting your arc. Also, another challenge with those is
when he says arc, what does that mean? Like, is that like when your current alternates between, I don't remember what the two are called, but basically AM and FM, like every time it does that,
they will usually only output direct current for TIG, so you won't be able to weld aluminum very well with those multi-process machines. Though there are a few that will output alternating current as well and do everything. So just make sure you know what you're.
So direct current is like leaving a light bulb on in your house and it gets too hot. And alternating current is like, I have no idea what alternating current is like.
You're looking for, and that it will do what you're going to want to do with it. One last thing to keep in mind with the multi-process machines is your MIG and TIG shielding gas will probably be two different types of gas. So make sure to keep that in mind.
Your MIG and TIG are different gases.
You need to purchase 2 gas cylinders, which will increase the cost a bit. So if you want to learn how to do one or all of these processes, check out the videos I've linked down in the description below, as well as some links and equipment reviews that you might want to use. We'll see you next time.
But how much they cost, man? It was a good video. I might be looking a little bit more into welding, or just like, I don't know, maybe some like wood stuff, like wood carving stuff. Sounds kind of cool. Tanning stuff. I want to learn a little bit about that. Cause I was, when I was like 7, I learned how to like, I was told that you can like brain hide or brain tan stuff. That's about as far as I got on that. I think I like did it like one time. It was super gross. Yeah, thanks for hanging out if you made it to the end of the video.